If we are given with differential equations that are actually considered as first order differential equation, it's also known as linear equation, we also have other method in solving such. We are going to use here the idea or the formula for solving a linear equation, specifically the first order differential equation. But first, we need to understand how do we solve or how do we find the integrating factor mu sub x. The first thing we need to do for this equation here is to make sure that this is already in its standard form. The standard form for a first order differential equation, which is identified as a linear equation, is in this form. The first derivative of y with respect to x plus p of xy equal to f of x. If we can transform our given equation into this form, where the right hand side is an equation in terms of x, and we have here this form in terms of the first degree of y, then we can actually come up with a certain p of x and f of x that we can use for our integrating factor. Our given here, dy over dx minus 3y equal to 0, already follows the standard form of a linear equation. That would mean our p of x here is this value except for y, and our f of x is this. So our p of x here is minus 3 or negative 3. Very important to include the sign. And our f of x is 0. Now we will be using p of x and f of x on our integrating factor. This will be used in solving this linear equation. The integrating factor mu of x is given in this form. We have e raised to the integral of p of x dx. By the way, we will not be using yet f of x. It will be used later in the part of the process. But for our mu of x, our integrating factor mu of x, we're just simply going to use p of x here. In short, for this given equation here to be solved, we need to get the integrating factor e raised to the integral of p of x, which is minus 3 dx. This would mean we have here e to the power of negative 3x. We may not include plus c in this case because we are just simply showing the integrating factor here. This is the integrating factor of our given equation, and we will be using this later on a separate video in solving for the given equation. Thank you very much for watching.